first, the important thing is you want to show that it's power supply. If you take the AC circuit, so definitely their source is actually the AC. And how what is the difference between AC and DC source? So that you want to remember that. Just hold on. Okay. So this is the difference. For AC source, we are showing one circle, and inside that circle, we can show here one sinusoidal waveform. Okay, so meaning is that that is the AC source. And if you take a DC circuit, so definitely there is a DC source. So difference between AC and DC source is that here we are showing one longer line and one shorter line for showing the positive and negative of the supply. So this longer line is normally denoted by positive terminal of the voltage source, and shorter line is the negative terminal of the voltage source. So this is the main difference you can show. And in both the cases, you load you can just show in a rectangular box, and you can write, instead of that you may show their resistance or inductor or capacitor. It may be anything. Load may be anything. So load you can show same in both the cases. Then another difference, just hold on. Then the second difference between the waveforms. What is the difference between AC and DC voltage? So that also you can show here. So for that you can see here this waveform is shown. So on y-axis normally we are taking the magnitude of the source voltage, whatever it may be voltage, it may be current. Okay, so on y-axis we are taking the voltage or current, and on x-axis we are taking the time period, means time period required to complete one cycle, or from that we can calculate its frequency also. So for AC voltage, definitely its voltage level may be different in every case. But if you take the AC voltage source, so it is a, as its name is, a alternating current. Alternating current means its polarity will be continuously changing. Magnitude also continuously changing from. So how it will be changing? So you can see here, from here, this is the starting point of this waveform or voltage. So from here, from this reference voltage, it will go on increasing. Then it will reaches to its maximum value. Again, it will become zero, and it will zero in this way. So this will be continue as long as source voltage is there. Okay, and so this is the nature. We can say this is a sinusoidal nature. But when we are talking on a DC circuit, so that DC voltage means it is a direct current, means it voltage will level will not be changing continuously. That will be the fixed here. So here also we are on y-axis we are taking the voltage, and on x-axis we are taking the time period of the waveform. And as it's we can say it is a direct current, means it is not an alternating current. It is not changing current. It is a direct current, means it's a DC current. So its voltage level is always constant with respect to time. So that waveform you can show like this. Okay, so this is the main difference between AC and DC voltage. Then the next difference is polarity is not important. It will be changed after the every half cycle. So meaning is that, suppose if you have AC load may be anything. It may be motor, it may be uh, All these are actually the AC loads. And while connecting that AC load across any voltage source, so that time that equipment have maybe two wires. So that time you can connect to any terminal anywhere. Means if suppose that equipment have suppose two wires, one is the red wire and another is the black wire. So normally, as per color code, we can connect red wire to the phase terminal of the voltage source and black wire to the neutral terminal of the voltage source. So according to color codes, we have to follow that. But still, by mistake, if you are connected in opposite directional, then also it will nothing will be happen. It will not be harmful to equipment as well as user also. So means that's why polarity is not important, as it will change because that polarity will be changing after every half cycle. So from this waveform also you can say this will be changing from 0 to positive, then 0 again it will be going negative. Means that polarity supply will be continuously changing from positive to negative, negative to positive. That's why while connecting any load, so don't think on polarity for AC source. But if you take a DC source and if your load is having DC supply, so that time you have to ensure about polarities. Means suppose this is your load and it has a polarity. Suppose this is the positive terminal of your load and this is the negative terminal of load. So while connecting this load across this supply, you have to ensure that whether you have connected this positive to positive terminal of the power supply and negative of terminal of the load to the negative terminal of the voltage source. So it is important while connecting the DC load. Then the next important again difference is that frequency is having the specific value. So what is the meaning of frequency? Frequency is means the time required to complete the one cycle, that is nothing but the means within a 1 second or within a 1 minute how many cycles are completed. From that we are going to able to calculate the frequency of the waveform. Normally we are saying whatever electricity supply available in our houses or in your hostels or in our laboratories or in classrooms, anywhere whatever supply is getting from the electricity board. So normally we are saying that supply voltage is having frequency 50 hertz. So meaning is that what is the meaning of 50 hertz? Means suppose I told you AC voltage is continuously changing from 0 to it. Suppose this is 230 volt, again it will become 0, again it will become minus 230 and again it will become 0 and again it will be continue like that. So within a 1 second, within 1 second, this kind of 50 cycles are completed within a 1 second. That's why we can say the frequency will be there 50 hertz or 50 cycles per second. Also, we can say. So that is the meaning of frequency is having the specific value. So in India, actually, this frequency is 50 hertz. Maybe in other countries, if you are seen some of the gadgets, so on that also it is written that it is operated on 60 hertz and 110 volts. So that voltage level and frequency may be different according to different types of countries. In maybe in some of the ships, line voltage is actually 60 hertz. Those ships are manufactured from other countries. Then last difference is impedance. Impedance is the combination of resistance plus inductance plus capacitance. Means if you take any load, suppose any most of the AC loads are containing actually the resistance plus inductance plus capacitance. Suppose if you take an example of motor, so in that that load is called as actually resistive plus inductive, because in the inside the motor there are two windings, stator winding and rotor winding. Okay, So that winding is, what is actually the winding? Winding is nothing but it is a copper wire made up of multiple turns wound on a former, and these kind of coils are fixed or mounted inside the motor. So means even though if it is a pure, even though that windings are made from a copper wires, then also it is offering somehow resistance. Okay, so it means it will containing somehow resistance of that, but due to that winding, or due to that multiple turns are wound, so they will form the inductance, and that inductance is also offering somehow resistance. And the combination, same way, the combination of resistance plus inductance plus capacitance, so that is called as actually the impedance. So impedance is nothing but one of the type of resistance, but it is the combination of resistance, inductance and capacitance, and normally it is denoted by R plus Z, sorry, that impedance is normally denoted by Z, and that Z is equal to R plus J plus minus J inside bracket reactance of inductor minus reactance of capacitor. So in this way you can write this. But in case of DC, impedance is actually the resistance only. Means in most of the electronic circuits, because most of, means all the electronic circuits works on only a DC power, and they are containing normally resistances. So that will be denoted by, means that impedance of electronic circuit is normally denoted by Z, and it will be purely resistive. So this will be the, these are the five differences between AC and DC circuit that you can write here. So up to this point, everybody understood this?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. Now,
Sir, is this PDF available on the LMS?
it is not available, but I will share to everyone after the completion of this chapter. Okay.
Okay, sir.
Okay. Now we want to see actually what happens when resistances are connected in series, or how to calculate the resistances when connected in series or in parallel. So here you can see I have shown here three resistances R1, R2 and R3. These are the three resistances. And when these three resistances are connected in series, so that time what will happen? So what is actually the very first, you have to understand what is the difference between series resistance and parallel resistance. So resistor have actually, you know, any type of, if you take any resistor, it has only two terminal. In some of the cases you may find there are three terminal also, but that is not the fixed resistor. That resistor is actually called as variable resistor. That's why that kind of resistor have three terminal, and the symbol of that variable resistor will be something like this. So its some symbol will be something like. So we are not talking here about variable resistor. We are talking here about fixed resistor. So R1, R2, and R3 is having value fixed. Okay. So what will happen? Suppose this is the terminal number one of resistor number one, and this is the terminal number two of resistor number one. Same way, again resistor number two is having two terminal. So this is the one terminal, and this is terminal number two. Okay. So we want to see actually what is the difference between series and parallel combination. Suppose if I am connecting this terminal number two of resistor number one to terminal number one of resistor number two, then this kind of connection is called as actually the series combination. This is called as series combination. Or if we uh, connect multiple resistances in series, likewise R3 and R4, if you connect multiple resistors in this form, that is called as series combination. Okay, just hold on, I'm going to clear this. And when we are connecting this series combination across any voltage source, so that time what will happen? That also we want to see here. But before that, see here, if R1 is connected, R2 and R3, when all these three resistances are connected in series, so that time, if we connect, that time we will get the addition of resistance. Means equivalent resistance of this whole network will become the addition of these three. Suppose, for example, the value of this resistance is suppose 10 ohm. The value of this resistor is say 5 ohm. Okay, and value of this another resistor is say 2 ohm. Okay, so that time what will happen if we connect here any ohm meter? Suppose I am showing here the symbol of ohm meter. This is the symbol of ohm meter. So that time what will happen? We will get the addition of three resistances, 10 plus 5, 15 plus 2, 17. Means here we will get the addition of three resistance, because it is a very simple, three resistances are connected in series. That's why simply we will get the addition of resistance. But what happen when I am connecting these three resistances across any voltage source? Suppose this is my voltage source and its value is suppose here uh, 10 volt. Suppose this is the value of this voltage. So that time what will happen? This 10 volt will be divided across these three resistances, because we know the resistance value is here 17 ohm according to our previous value. Okay, because three resistances are connected in series. So from that, whatever value of current is flowing through that three resistance, so that value will be same, always same. Because if you want to calculate that value, so that also you can calculate. So suppose in previous example, we have calculated the resistance value is 17 ohm, 10 plus 5 plus, once again I can write here, this is 10, this is 5, and suppose this is 2. Okay, and suppose according to Ohm's law, I can calculate this current. So this current I is nothing but I is equal to V upon R. Okay, so this is the formula for that. We know the value of voltage is here 10 divided by the resistance value is 17, and after calculation of this, whatever value of I is getting, so that value of current is flowing through R1, same value of current is flowing through R2, and same value of current is flowing through R3. Means current flowing through this whole circuit is same, it will not change, but there is a division of voltage. Meaning is that whatever voltage you are giving from this voltage source 10 volt, so that 10 volt supply is divided across these three resistances. Means some of suppose here voltage is uh, drop suppose 7 volt, maybe here voltage is drop 2 volt, and here voltage drop is 1 volt. So this is just I have given example. This is not the true value. Okay, this just I have given the example. Means here voltage is 7 volt, because here resistance value is greater. That's why here voltage drop is also greater. Then here resistance value is 5. That's why here voltage level